So the first step we had was just to read, to take in an image without without the yellows and the lines. That's what we added on top of the filter. We'd be given in just an image with just white lines. So to first read the road, we started by iterating, so to speak, row by row from the bottom up, and our program goes out from the center to look for any pixels that are white, and once it finds a white pixel, it marks that as a yellow road line. And then from the yellow road line, we can create, we average out those 2 points to get this center line, as you can see in the middle. And that was kind of the trajectory that we wanted to take with our car. And then the cyan point is the steer point, which we'll get into more in depth in a second. Though problems that we had with this was occasionally as it went around a corner, one lane of the road would be gone and out of view, and you obviously don't have an average to take from that. So we had to add some code and program some specific things to have find just one side of the road and steer off of that. Basically how that process works is it finds the left lane just as normal, and if there's no right lane on that row of pixels, it translates that lane either left or to the right to guess where the center line would be, and that's how we solved that issue. So then to follow the road, after we have this cyan point, we can then the goal is to calculate the angle between the cyan point and the center of where our hood would be. So this line here indicates the middle of the screen and of the camera that we're being passed in. And we know this x value, the distance, or the x offset is what we called it, and we know the y, the height of this triangle. From there we can use arctangent to find the degree that we need to turn either left or right, and that helped us save the road and give a nice smooth turn.
And so once we had our basic turning done, we want to start tackling more advanced turns, and to do that we decided that we would need to be able to have an accurate map of the track. And so we began work on code to basically log our current position and heading as we're going through the track based off of the motions that we're taking. So it records the heading by knowing how we're turning and recording that and doing the math to determine basically what x and y offsets and what angle changes it makes by having a certain turning radius. And then from there, knowing our current heading and our speed, you would iterate how much distance we had traveled over each frame. And using all of this data stored in an array, we recreated the track in a map, and we had specific logic to determine whether or not we were in a curve. And we marked that by having blue for determining we're in a curve, and then the green points marking the start and end of each curve, and then just the red for straightaways. And we hope to be able to use this in future years to be able to accurately follow the racing curve, to take curves more smoothly the way a more experienced driver would take them. So a racing curve is basically the curve following it's the line following a curve that has the largest turning radius, so the car is under the least amount of stress while it's going through the curve. And it basically involves starting at the far end of the curve, cutting in through the apex, right the close end of the middle of the curve. I guess it's not really with so it starts at the far end of the curve, cuts into the apex at the inside of the curve, and then goes back to the outside of the curve. And that results in a very large turning radius, which you can take a lot more gently than just flowing through the middle of all of it. And that will allow the car to generally travel at faster speeds, which we hope will be very successful